So we're going to do exercise 735. That's on page 343. Again, I believe it's one of your homework problems, but it's okay. As long as you can use whatever information in this problem to apply to other problems, I'll be deeply happy about that. So 735 tells us that we are to determine the average normal stress in each of the members of this particular truss. So it tells us that we have a diameter is 20 millimeters, okay, and we are to assume or to set our P, our horizontal force P, to 40 kilonewtons. So as you can see here, I have a diagram here of this particular truss, and it tells us at A the type of pin mechanism that this particular truss is being held down to, and then also at B we have a roller. Okay, A we have a pin, B we have a roller, and at C we have a horizontal force of 40 kilonewtons pulling at joint C. So just kind of looking at this problem, the first thing that came to mind is, well, since I have pins, I have a roller and I have a pin, you know what? Let me find out my support reactions. That was my first thing that came to mind, right? So in drawing my free body diagram, I have my support reactions AY and AX, okay? And then since why does B have only one support reaction?
Roller.
Exactly. Okay. And one thing I also did as well, I just multiplied the distance, like 2 meters and 1.5 meters, just by 2 to make things easier. Yes, sir.
Yeah. So if you make that a 3, 4, 5 triangle,
Mm-hmm.
Do you have to use similar triangles to make the force at the top bigger?
No. Just all I did was just really multiply the distance just by multiple of 2, just to give me so just to minimize the complication of my math.
So, but if you do that,
like a 40 kilonewton force at 1.5 meters is going to be a different moment than a 40 kilonewton force at 3 meters.
all cancels stuff out there.
Does it?
Yeah, we'll see as we go along. Okay, but great question. Okay. Okay, so we have the 3, 4, 5 triangle, right? Now, why would I take the moments about point A? Why not B initially? Exactly. Okay. So at moment of point A, the moment about point A, of course, to take out AX and AY. So I'm only left with BY, right? And when I do that math, this is what I get, 30 kilonewtons, right? Then I can jump straight. My other equilibrium equations I can jump straight to is some of the forces in the X direction, right? Now I know what BY is. I know what the force at point C is, which is 40 kilonewtons, and I can solve for AX, which will be 40 kilonewtons, okay? And then when I look at the sum of the forces in the Y direction, right, I have, now if you notice that I have 2 colors here, right, and that's because initially I chose the wrong direction. I chose my AY to come down rather than go up, okay? So you just want to make sure that your support reactions are positive, and then you want your arrows to reflect that, okay? And that's what I did here. So my AY is a positive 30 kilonewtons. Okay. Now, once I found out my AY and BY and AX, I'm just going to populate that here. The BY was 30 kilonewtons. My AY was 30 kilonewtons. And my AX was 40 kilonewtons. All I did was just populate that in my free body diagram, and they're being boxed by a blue marker. Okay, I'm going to go to step 2 now because they want us to determine the average normal stress in each bar, right? So what would be the formula for our normal stress? Exactly. So I'm going to put here the stress, which is, this is the symbol, like tau would be for shear, okay? This is sigma. Yeah, this is a Greek letter sigma, okay? Oh, this one, like this. Tau, that's tau. That's for shear stress. Okay, now these, for most textbooks that you'll find on the market, they're going to typically use these symbols. Now, you may find something different. They may use, you can use K, you can use Z, as long as you just identify what it is to let people know and follow you, okay? So our normal force is nothing more than the force over the area, right? And they're both forces over area. This is also force over area, right? But what will be the difference in the force for each one?
Direction.
How it comes in contact with the plane, yes. Okay, so for the normal stress, which is normal stress, what happens is you have a rectangle here and the force is always perpendicular to that face. Does that make sense? So if I draw a cube, something similar to this, the force is always going to be perpendicular to that face. Okay? Now what about a shear stress? How does that?
Parallel with the face.
Parallel with the face, exactly. Okay? So kind of keep that in mind because we're going to need that as we go on as a function of time, okay? Okay, so now we know what the force, they asking us what is the average normal stress. So we're typically going to use this, as Vanessa said, we're going to use this equation here. So we need to find out what are the forces in that member, right? So I guess this, taking joint A, right? Joint A, and everything is going to be in tension. So we have to our right force AB, then we have our support reactions AY and AX, and then we have force AC. Now, I can use my equilibrium equations, some of the forces in X direction. Since I already know what AX is, right, I can find FAB, right, which we found here. Then some of the forces in the Y direction, since I know what AY is from my support reaction, I know what FAC is, okay? And FAC is in compression, okay? Keep that in mind, okay? Now the next step was I'm going to go to joint B because I need to find out, we have 3 bars here. We have bar FAB, bar FAC, and bar BC. So we found FAB and AC. We need to find BC. Okay? So I will come again. Again, this is all in EGT 136. I'm just using that knowledge. That's what I knew how to do first. And I just did that first and see where that takes me. So now I need to find out what FBC is. So I'll draw, again, a free body diagram of joint B. And then we know that our force BC has both the X and Y. And all I did was just split it up into the X and Y components. And then I just took the sum of the forces in the X direction, which gave me negative 50 kilonewtons, which tells me that that particular bar is in compression. Okay? Now, my next step, now that all I did right here was just typically label or spell out force BC, force AB, and force AC, because they want us to find the normal stress. In each member. Or bar, as they call it. Okay? So as we know, my step 3, I'm calculating my normal stress now, because I found the forces in each bar using method of joints, okay? And now I want to calculate my normal stress. So my normal stress, as we have outlined, is nothing more than force over the area. And they told us that each bar is 20 millimeters in diameter, right? So for force BC, it's a negative 50 kilonewtons, right? And the area, instead of me using, and this is what kind of mixed me up in the past, I don't know if I expressed this though, but you can either use, for area, you can either use pi d squared over 4 or pi r squared. They give you the same thing. But the thing is, if you don't remember, if you use pi r squared, if you don't remember to divide your diameter by 2, it will give you an incorrect answer. Yes, sir.
I might be wrong, but isn't it supposed to be 0.002?
Yeah, it was 20. It's 20 millimeters. Yes. Yes, it's 20 millimeters. And that happens a lot. That happened to me actually when I was doing this. So yeah. So just, I kind of do things a long way so I don't miss anything. You know, so 20 millimeters divided by 1,000 will give you 0.020 meters. Okay. So all I did was just square it. And then it's 159 megapascal. What does M stand for again? Okay, 10 times 10 to the 6. Okay. 6 orders of magnitude. Okay. And I have here, so if you, I don't necessarily have to put a negative in front of it because it's already compressive. You know, so that's why I've outlined here is it's in a compressive state. Okay. Now the next step is, what about AB? So I know the force in AB, right? We found that from our method of joints, and that's 40 kilonewtons, as you can see here. It's 40 kilonewtons right here. So, and that will be divided by the same area, which you'll get 127 megapascals, and that's in tensile because our force is in tension. Okay, and then the last one, the last stress will be normal stress. The normal stress at AC, which would be force over area, and that was a negative or a compression of 30 kilonewtons over the area, and that's 75 megapascal compression. Okay, so that concludes really this particular exercise. Again, all I did was I just started with I know first. I need to find the force because I know they want the stress. So stress is force over area. And how would I calculate the force in each member? Well, let me try method of joints, because if I take a joint analysis of this, I can get my force in each member. Then from there, they already gave me what was the diameter of the bar. So from there, I can find the area, and that's typically the approach. Okay, so you just kind of figure out what they're asking for, what do I know how to do, and then start from there, and then you see that everything will just evolve. Okay, any questions? Any comments? Okay, I'm going to stop this particular video.